So if the circuits are parallel, if two or more components are connected in parallel, example, you have a 18-volt supply, which is connected to a 2 ohm and 8 ohm resistors which are in parallel. So which quantity will be same for these resistors? Current or voltage? They are in parallel. Which quantity will be same for both resistors? Current or voltage when they are in parallel?
Sir, current will be same.
Current will be same. What about voltage? Actually, when the circuits are connected in parallel component, they will have the same voltage. So if this is a 18-volt supply, this will receive 18 volt, this will also receive 18 volt. So in parallel circuit, the voltage across the component is same. And in series circuit, the current which is passing through the component is same. So
But
if
the
it's a,
current will be, yes, yes.
the current will divide here between the two components, but they will have the same voltage. So when resistors or other components are connected in parallel, at every point the potential difference or voltage will be same. So you can see if it's an 18-volt supply, both will receive 18. But how much is the current? If the current will be equal to the sum of current passing through individual branch. So example, what is the current here? So how I can find the current? I have the formula V is equals to IR, or R is equals to V over I. So I is equals to V divided by R. The voltage here is 18 and the resistance is 8. 18 divided by 8. What's the answer? 18 divided by 8. So 2.25. 2.25 ampere. So means 2.25 ampere is flowing from here. And if I need a current at this one, so current is equals to voltage divided by resistance. Voltage across this is 18 and resistance is 2. So 18 divided by 2, that's equal to 9 ampere. So 9 ampere in the second branch. So if I say what is the total current? So total current will be the sum. So what is the total current? It will be equal to 9 plus 2.25. So you can see 11.25 amperes. So the current in a parallel circuits divide between the component and the voltage is same. And opposite will happen. Current in the series circuit is same, where the voltage divide between the components. Is it clear? So you can see here the current across 8 ohm was 2.25 and across 2 ohm it is 9, and the total current is equals to the sum of current which is passing through individual branch. So if you have you have to remember this. If you have a series circuit, if a circuit is series, they will have same current, different voltage. That means voltage divide. If you have parallel circuit, they will have same voltage, but the current will divide between the components. Yes, Salman?
Sir, small question. Sir,
Yes.
why in parallel the current is same again?
No, in parallel, the voltage is same.
Sorry, the voltage is same, and why in series the
Yeah,
current is same?
because the reason is that, look, when I say it is 18 volt, so when one charge will come out, how much energy it will carry? When 1 coulomb
80.
of 18. So when this 1 coulomb is having 18 joule, when it enter here, it has two possibilities. Either it can take path 1 or it can take part 2. So example, if this take the second path, so before entering it will having 18 joule, after passing it uses all of its energy and go to the battery. So how much energy it supplied to the resistor? What will be the potential? 18. But it's not like only one charge is there in the circuit. Continuously the charges are coming from the battery. So then there's another charge which is coming out from the battery, and that also carry 18 joules because the supply voltage is 18. So as the second charge enter the circuit, it also carry the same energy. So if the first charge follow the second path, then the second charge will follow another path. So example, it will move up. So before entering, it was having 18. After passing, it will have 0, transfer all of its energy, because there is no other component it has to pass through. So that's why it use all of its energy. So both will have same amount of energy transfer. That is why both will have the same voltage as what is supplied by the battery.
Sir, but why is current different?
Why the current is different? What is the meaning of a current? Current means the flow of the charges in a unit time. Example, these two charges were coming and it was moving in 1 second, okay? Flowing. So two charges in 1 second. But what happened? The charges separate. Now it is one charge per second. So if it is one charge per second or 1 coulomb per second, what does it mean? It means the current will be 1 ampere, because the current is the flow of the charges or number of the charges moving in 1 second through it at a specific point. So here you can see the number of the charges divided. As the number of the charge divides, so coulomb decreases, it means the current will also decrease. So
Uh,
what entered the circuit was two charges in 1 second. So there was a two charges. If two charges in 1 second, it means what is the current they will produce? They will produce 2 ampere. But as these two charges enter the branch, one charge follow branch one, another charge follow branch two. Sorry. So what happened? Now it is 1 coulomb per second. So as there is one charge per second, so what happened to current? The current here will be 1. Here also current will be 1. But as they rejoin again two charges per coulomb. So that's why the same number will return. Is it clear?
Understood, sir. Yes,
So
sir.
current is actually a flow of the charge, the movement of the charge. But here, what in a series circuit, why the current was same? Because example, if two charges are moving in 1 second, so same number will flow throughout the circuit. That's why the current is same. But why the voltage is different? Because when this charge, one of the charge, it's having 16 joules. But when it enters, some of the energy is transferred, like it was having 16, then maybe it will have 10 joule, and then it will have. So before entering, it was having example 16, then it was having 6 joules, and then 0 joules. So how much energy transfer from 16 to 6? It transferred 10 joule. How much energy transfer from 6 to 0? It transferred 6 joules or 6 volts per 6 joules per coulomb. So energy transfer divided between the component. That's why the voltage divide, but the current, the flow of the charges remain same at any point. That's why the current is same. So in series circuit, the current is same, where in parallel circuit, the voltage is same across the components. Now, what is the advantage of connecting electrical components in parallel rather than in series? So what happened? Look, I discussed this point yesterday. It's just a repetition. Example, there are some advantages connecting the lamp and other component in parallel. Example, these lamps required 6 volt to work. So I have a 6 volt battery. How much voltage across this lamp? 6 volt. How much? 6. But if I connect them in series to a 6 volt battery, so the voltage will divide between the lamps. So which case the lamp will be brighter, in parallel circuit or in series circuits? Brightness
Parallel.
here, parallel circuit, because more energy transfer by each charge, so it will be brighter. And another advantage, if for example, if this lamp is not working, So if one of the lamp is faulty, or if one of the lamp is not working, the whole circuit will stop working. But if here one of the lamp is not working, the other component will still work, because there's another path, there's another passage for the charges to flow. So the charges can flow through this passage. But here, because there is a block, like there's no complete circuit, so charges will not come out from the battery. So the components work independently and they receive the same voltage. Is it clear? This is the same thing written. Voltage through each lamp is same, so each lamp has same brightness. And if one lamp is melt, the other lamps will not work, but in series. Other lamps will work, but in series, if one lamp melt, the other will not work. So this is about the electrical circuit. We discussed voltage, current. These are some circuit symbols. You have to learn these symbols. With the time to time, I will use these symbols and I will let you know what is a symbol for. So when you draw the circuits, you will learn these symbols as well. So example, draw a circuit diagram, 1.5 volt power supply, two bulbs connected in series, a switch, ammeter to measure current through the circuit, and voltmeter across each bulb to measure the potential. You can use the screen annotation to draw this circuit. .5 volt power supply, two bulbs in series, a switch. So 1.5 volt, you did 1.5, two bulbs in series, switch is there, and voltmeter for each. That's so this is the last question for today's class. We will do now, from next week, we will do the circuit questions from different past papers. And these circuit questions are same like the topic salt and identification, which is having a greater weightage in your paper. So this is also important topic, solving the questions related to circuits. So I'll end the session and share the recording. Send this circuit diagram on WhatsApp.